Imagine a software team working on a big project, except every morning when a new developer shows up for their shift, they have absolutely no memory of what happened yesterday. No idea what was built, what's broken, what's half finished. They just start fresh. That's essentially what happens when you ask an AI agent to work on something that takes longer than a single conversation. Context windows are finite. Even the biggest ones eventually run out. And most real projects, building an app, writing a code base, doing serious research, can't be finished in one go. So the agent works for a while, hits its limit, and then a new session starts. Blank slate. This is the long-running agent problem. And in November 2025, Anthropic's engineering team published the paper on how they're trying to solve it. Their test case was ambitious. Get Claude to build a functional clone of Claude.ai. Not a toy demo, a real web app with hundreds of features. Chat interface, conversation history, theme switching, the works. Out of the box, even with their best model, it didn't go well. The failures fell into two patterns. First, Claude would try to do too much at once. It would attempt to one-shot the entire app, run out of context mid-implementation, and leave the next session to inherit a half-built, undocumented mess. That next agent would then spend most of its time just trying to figure out what happened and get things working again. Second failure mode, and this one is almost funny. After some features had been built, a later agent would look around, see that progress had been made, and just declare victory. Job done. Ship it. So Anthropic's solution came from an unlikely place. They looked at what good human engineers actually do. Think about it. When you join a project midstream, what do you need? You need documentation. You need to know what's been done, what's left to do, and what state things are in. You need clear commits with descriptive messages. You need a way to test that things actually work. The insight was agents need the same things. Their solution has two parts. First, an initializer agent. This runs once at the very beginning, and its only job is to set up the environment. It creates a progress file, basically a running log of what's been done. It writes an init script so future agents know how to start the dev server, and critically, it generates a comprehensive feature list. For the Claude.ai clone, this meant over 200 specific features, each described in plain terms. A user can open a new chat, type a query, press enter, and see a response. Every feature starts marked as failing. This feature list solves both failure modes at once. The agent can't one-shot everything because it's been explicitly told to work on one feature at a time. And it can't declare victory early because there's a clear, objective list of what done looks like. The second part is the coding agent. This is what runs in every subsequent session, and it follows a specific routine. When it wakes up, it doesn't just dive in. It runs pwd to see where it is, it reads the git logs, it reads the progress file, it checks the feature list to see what's done and what's not, it runs the init script to start the dev server, and then, this is key, it runs a basic end-to-end test before doing anything else. Why? Because if the previous agent left things broken, you want to know immediately, not after you've started building on top of the mess. Only then does it pick a single feature to implement. And when it's done working, it doesn't just stop. It commits its changes with a clear message. It updates the progress file. It leaves the code base in what the paper calls a clean state, the kind of code you'd be comfortable merging to main. No half-finished functions, no unexplained hacks. There's one more piece that turned out to be crucial: testing. Left to its own devices, Claude would often mark features as complete without properly verifying they worked. It might write unit tests or run some curl commands against the server, but it wouldn't actually test the feature the way a user would experience it. The fix was giving Claude browser automation tools, specifically Puppeteer through an MCP server. Now the agent could actually open the app, click buttons, type in fields, and see what happens, just like a human would. This dramatically improved results. The agent could catch bugs that weren't obvious from looking at the code alone. Though some issues remain. Claude can't see browser native alert modals through Puppeteer, so features that relied on those tended to be buggier. What I find interesting about this paper is how unsurprising the solutions are. Progress notes, clean commits, a checklist, proper testing. These are just good engineering practices. The insight isn't some clever algorithm. It's recognizing that agents face the same coordination problems humans face, and that the solutions humans developed over decades of software engineering actually transfer pretty well. The paper ends with some open questions. Would specialized agents work better than one general-purpose agent? A dedicated testing agent, a code cleanup agent, a QA agent? Maybe. And can these patterns generalize beyond web development? Scientific research, financial modeling, other domains where work spans many sessions? Probably, but that's still unexplored territory. For now though, if you're building systems where AI agents need to work across multiple context windows, the lesson is clear. Treat the agent like a new team member showing up for their shift. Give them good documentation, clear tasks, and a way to leave things better than they found them. It's not rocket science, it's just good engineering.